Last chapter, chapter 14, solutions. So I think we probably all know that we shouldn't drink seawater, ocean water. For one thing, it tastes really terrible, right? It's like incredibly salty. But why? Why would it be bad for you? And you say, well, why would I even want to drink it? Well, if you were stranded on a boat out in the middle of the ocean and had no water to drink, it might be tempting. But if you drink seawater, it'll actually make you more thirsty and more dehydrated than if you don't have any water at all. Because seawater actually will draw water out of your body as it passes through. Seawater is a solution. And when chemists talk about solutions, we're talking about a homogeneous mixture of two or more substances. Remember that homogeneous means it's the same throughout. So the concentration is equally distributed. The top is just the same as the bottom. There's no visible difference in it. In seawater, water is the solvent. That's the major component. And then sodium chloride, salt, is the primary solute. So a solution consists of a solvent with one or more solutes dissolved in it. You could have more than one. I mean, you could take a glass of water and you could put some salt in it and stir it up, and the salt dissolves in the water, right? You could add sugar and dissolve that as well, right? Now you've got two solutes. Water is the solvent. Usually the solvent is in our, what we do in chemistry. Usually it's water or another liquid. Another way to identify it, though, is which one is there more of. So nature has a tendency towards spontaneous mixing. So here, if we imagine this is like a fish tank, right, with a barrier in the middle, and we've got pure water on one side, and we have salty water on the other side, maybe from the ocean, right? If we take this barrier out, just pull it out very slowly, not to disturb anything, is the salt water going to stay on this side? No, it's going to mix, right? The salt water and the fresh water are going to mix together because that's what nature does spontaneously. Things mix. So if you're drinking seawater, nature's tendency towards mixing will cause water from inside your cells to go into your intestines. So here we have, there's your stomach and your intestines. So here we have inside your body, and this is technically, did you realize when something's in your stomach, it's not actually in your body because it's just like a big hole going through you, right? You're like a donut. So that's really kind of on the outside of your body. Okay, there's your mind blow for today. But the cells, the cell membranes can allow water to pass through them. And so nature's tendency towards mixing says, well, I've got a concentrated solution over here and a less concentrated solution over here, and everything needs to be the same. So it wants to mix them. There's a barrier here that doesn't allow the salt to move, but it does allow the water to move. And so the water molecules will go through this membrane over here, making this more dilute and making this more concentrated than it was before. And it'll keep doing that until the concentrations are the same. So drinking seawater, your body isn't getting any water from it. That is actually taking water out of your body. Does anybody have any questions about that? Kind of weird.
I just wondered about when you drink an energy drink or like that has like electrolytes or something in it. Isn't that technically like it has salt? So why is it that will hydrate us? But then
That's a good question.
won't
So why would you drink like Gatorade or something with electrolytes in it, which is it's got salt. It's got different kinds of salts, not just sodium chloride. Why would you drink that, and why would that be helpful? That's only helpful if you have been sweating profusely, because when you sweat, your sweat contains a lot of salt, right? Sometimes your sweat's running down your face and it runs in your mouth, and you're like, oh, that tastes salty. Yeah, it is salty because you're sweating out those electrolytes, those salts that were in your body. Well, you sweat out too much of that, now your salt concentrations are going to be getting low. And so, here we're looking at the intestine. In your stomach, I believe, don't quote me because I'm not a biologist, there are parts of your digestive tract where it can absorb those salts and take those in and get those into your bloodstream. And sugar, that it's not happening in your intestines though. But yeah, if you're not sweating profusely, if you're just a little bit sweaty, you're much better off just drinking water than something with all those electrolytes. Most people don't need those. The high school football players that are out there in August when it's 106 in full pads, yeah, they need electrolytes. Us just, walking down the street, probably not. Good question. Anybody else have any questions?